Hello, everyone. Welcome to the Introduction to Algorithms episode. My name is Aracely Moreno, and I'm a freshman at Harvard planning on studying computer science and biomedical engineering. I will be the event supervisor for Harvard's Algorithms Online Open event. This video is the first of a series of lessons where the goal is to develop efficient algorithmic thinking and analysis necessary for the online open event and to carry on for future programming endeavors. So, what do I mean by algorithms? Essentially, algorithms are a set of instructions to solve problems. This broad definition leaves room for it to apply to our everyday lives. Now more than ever, you probably see posters or reminders about washing your hands, right? If you were to teach a child how to wash their hands properly, how would you do it? What happens if they ignore a step, such as rinsing their hands? Well, to answer the second question, the child might leave the bathroom without washing their hands properly. So, for any problem, it's essential that you meticulously explain each step so that your program does exactly what you want to do. But this raises another question: how many steps are too many? There are many ways to solve a problem, but not all of them are efficient. Can you think of another example of an algorithm in your life? Feel free to pause the video and reflect. Now, these other images essentially display the same concept of how algorithms exist in our everyday lives. However, this image here is a bit more complex and involves robotics and technical algorithms to solve. So now that we have a general idea of what algorithms are, why study them? If you are interested in pursuing computer science as a career, you should know that computer scientists learn by experience. You will be exposed to different problem solving techniques and when it's ideal to use each, but ultimately, you'll face different scenarios than the examples given in this course. Through these lectures and self studying, you can begin to develop pattern recognition as you become more familiar with the types of problems each algorithm is meant to help solve, which is great for technical interviews if you plan to do them in the future. Since the online open event will cover coding problems and understanding the logic behind algorithms, these lessons will assume that you have some foundation in programming. Occasionally, practice problems will be optional homework to supplement what you learn, so having some familiarity with the programming language is ideal. If you feel that you need more resources on concepts like variables, functions, arrays, or getting started on a language, feel free to reach out and I'll provide any tips and resources I can. Now, back to the lesson on the slide. So here we have two programs that produce the same output, but one is more efficient than the other. Can you guess which one it is and why? Pause and reflect. Okay, hopefully you picked the one on the right, simply because you can see logically that it involves less steps. There's less lines of code, there's less iterations. It just seems all around nicer than the first one. However, when we get to more complex and dynamic programming, it's hard to tell when one code is more efficient than the other, which is why we'll be deciphering the mysteries within our lectures. I want to remind you that we want this event to be as inclusive of all backgrounds in computer science as possible. Whether you're just started programming or have a myriad of repos in GitHub, the algorithms event is a perfect and free way to test what you know. So don't hesitate to reach out once again if you have any questions whatsoever. The topics we will discuss or range from basic algorithms such as searching and sorting to more advanced algorithms, dynamic programming, and data structures, as featured here. And so these images display some of what we'll talk about, such as the merge sort, which we will discuss in our first lecture, and other topics in data structures. Additional resources would be the Introduction to Algorithms textbook provided by MIT, but it's a bit expensive, so I recommend using the like online resources that are available to you, like such as YouTube or open courseware for MIT, which has this course in it as well. However, most of the topics we'll be discussing within this lecture or these lectures. What I would really ask you to do is basically get a LeetCode account. It's pretty useful, especially when you start practicing for technical interviews, because some of the problems you probably even see in your actual interviews, or at least problems that are very similar. And we'll be using some of these problems as homework assignments that you may choose to do. So it's helpful to get an account. Thank you so much for stopping by. And once again, if you have any questions, you can reach me via my email. And have a great day.